Okay, hey geometry kids. This is the start of chapter 10. Chapter 9 was all about triangles. Chapter 10 is all about circles. So this first section is fairly short and sweet. It's naming parts of a circle, things like that. Talking about circumference, which is the distance around a circle. So just starting into, I don't know, there's a lot of vocabulary words going on here. I'm going to refer to this diagram and let's talk about how you name. I'm going to list stuff off to the side over here. So how you name a circle. This guy is going to be called circle C. And so you can either write out the words circle C, or you can do a circle with a dot in it and call it circle C that way. But C is the center of the circle, so that's how you name this circle, circle C. Okay. Within a circle, there are radius or radii, the plural of radius is radii. There are actually 3 radii in this circle, and it doesn't matter necessarily how you, well, I guess usually we start with a radius and we go out. So one radius is CE, one radius is CF, and another radius is CD. So CE, CF, CD, those are all radius lengths. Radius is half the distance of the circle, across the circle, okay? Then you have a diameter. And this one only has one diameter, although you could have multiple diameters. If I had one, let's say, going through here or going through here, it's just all the way across the circle through the center, okay? So this one has one diameter, and that diameter is DE. Is that distance across, okay? And then we have another vocabulary word that's called a chord, C-H-O-R-D. And a chord just starts at one end of the circle and goes to the other end. Doesn't necessarily have to go through the center, okay? So this AB would be an example of a chord. DE, even though that is the diameter, is technically a chord as well. All it has to do is start at one endpoint of the circle, end at another endpoint, okay? So a diameter is technically also a chord, okay? CF, this guy is not a chord because C doesn't go all the way to the edge of the circle. Okay, that's what would have to happen in order for it to be a chord. So here's all some information. They're going to ask you that in your first couple examples that we do here and in the homework assignment. One more thing before we move on to the first example, though, the difference between radius and diameter. Diameter is double what the radius is. So 2 times the radius is the diameter, or they say the radius is the diameter divided by 2. Hopefully you know that already. I would guess that would probably be something that you would know. Circumference. This is a formula that you're going to have to memorize. This should, I mean, you probably already know this. The circumference is the diameter times pi, or 2 times pi times the radius. Because the diameter is 2 times the radius, you can say 2 pi r or diameter times pi. Now, circumference, just FYI, is the distance around the circle. So it's like if this was a pizza, it would be like the length of the pie crust going around, okay? We'll talk area here in a little bit. Well, not here in a little bit. We'll talk area tomorrow probably. But circumference is the distance around a circle, the distance of the pie crust around the edge of the circle, okay? All right, example 1, name the circle. I'm going to put name over here. And then identify a radius, a chord, and the diameter. Okay. Now, on your homework assignment, it says a radius, a chord, a diameter. This one's probably going to have multiple, like I know it has multiple radius or radii. You only have to name one. For this example, I'm going to name all of them. Okay. So the name of this circle is circle X. I think the center of the circle is X. Okay. A radius. There are 1, 2, 3, 4 radii in here. XV, XT, XU, and XZ. Now again, you only have to name one on your homework assignment, but I'm going to label all of them. So XV, XT, XU, XZ. Okay. A chord. There are technically 2 chords. This is one chord, and the diameter is a second chord. So RS and ZT are chords. RS ZT. And then there's one diameter, and that is ZT. Okay, so example 1, you're just naming stuff. Okay, example 2 is really short. TU, the distance from here to here is 14 feet. And that is the diameter, right? Because it's going through the center of the circle. They want to know what the radius is. Okay, well, the radius is just half of the diameter. So hopefully that was easy for you, 7 feet, right? Okay, moving on. Example 3, we have a story problem, and they have is this a roundabout? I hate roundabouts. I don't know if you guys have ever had the pleasure of driving through a roundabout. They have 2 of them up by Adams Central. They're awful. I hate roundabouts. They are circular roadways that reflow traffic in one direction around an island. A car enters a traffic circle and is 18 meters from the center of the island. Okay, so like let's say we're talking about this car. He is 18 meters from the center. That sounds like the radius. 18 meters from the center of the circle. If the car drives around the traffic circle until it's back to its original position, what is the circumference of the car's path? So they want to know the distance traveled around here and all that good stuff, okay? So circumference is 2 times pi times the radius, or the diameter times pi. I'm going to use 2 pi r because we're given the radius, and the radius is 18. So I want to plug just 18 in for the radius. 2, if you want to do some math in your head, you totally can. 2 times 18 is 36. So all I need to do is take 36 times pi, or you can just do 2 times pi times 18. You need to, though, make sure that you're not typing in 3.14 into your calculator and you're actually using the pi button, because the pi button will use the decimal of pi all the way out to the very end, and it will give you the most accurate answer. So, oh shoot, I gotta find let me use my calculator here. Give me a second. 18 times pi. I got 56.55, let's say. Do they tell us how they want us to round? No, they do not. So 56.55, and we are in meters. So there is the distance around the circle. Now, distance around the circle is not meters squared or anything like that. That's area. So just 56 meters is how far around that car goes around the roundabout. Okay? All right, let's go. Example 4. Now they're going to have us work backwards a little bit. Find the diameter and the radius of a circle to the nearest hundredth. That's 2 decimal places. If the circumference is 77.8. So they say this formula for circumference, I like their work here. Formula for circumference is pi times diameter, or you can say 2 pi r, whatever. But they're going to have us solve for the diameter first, which is totally fine. Circumference they're giving us is 77.8. So if I'm trying to solve for the diameter, all I need to do is divide both sides by pi. So I'm going to, and again, use the pi button. Don't use 3.14. So you take 77.8 and you're dividing by pi, and you will get the approximate diameter. And let me do that on my calculator. 77.8 divided by pi. And I got 24.76. They said 2 decimal places. That's what the diameter is, okay? Then they say they want us to find the radius. Okay, they say half of the diameter, whatever. We're just going to divide by 2, which is like taking half of it, right? 12.38 approximately. Okay, the diameter was 24.76. So half of 24.76, or taking 24.76 dividing by 2, gives us the radius, which is approximately 12.38. Do we have units? Yes, we do. Centimeters on each of those. Okay, not centimeters squared, just centimeters. Okay, so hopefully that was fairly easy. You're just plugging 77.8 in for C, and then just working backwards, so dividing by pi to get the diameter. Okay? All right, I think we just have one more example left. And it is, pairs of circles. Okay, here we go. Talking about different pairs of circles. Circles, here are things that can happen when we have 2 circles. Okay, think of these as like, I don't know, when you're blowing bubbles, right? Like outside you're blowing them through the little circle that has the soap on them or whatever, okay? So you have bubbles that are like sticking together, right? So I could have two bubbles, and usually they don't do this. Usually they combine into one when they're, you know, intersecting like that. But I could have two bubbles come together and touch each other at two places, right? Or I could have one larger bubble and one smaller bubble where they're still touching at two places, right? And those are points of intersection. So a circle can have at most two places where it's intersecting. It can't intersect at three places. That's not going to happen. Two is the most number of places that it's going to intersect. I might have a circle that's only intersecting at one place where they're touching just like right at the edge, or where one circle is inside of the other, and they're just touching at that one edge. Or I might have two circles that are not touching, no intersection. Did they put this up at the top? No, they didn't. No intersection, in which case I have one bubble here and one bubble here. Or I could have one bubble and another one inside of it, kind of like a target. And these are called concentric circles. Concentric means same center. Con means same, centric means center. So concentric, same center circles. These two circles have the same center. The inner center, or the inner circle and the outer circle, they both have the same center of A. So there's that. All right. Yeah, and they're both called circle A. So circle A with a radius of AB and circle A with a radius of AC. That's how you would distinguish between the two. But they're both technically circle A because the center is both A. Okay, so we have concentric circles. Now they're going to be doing two circles that are overlapping, and they're going to give us some lengths here. So it says the diameter of circle K is 12 units. Okay, circle K is the smaller one right here. This guy. And this says his diameter is 12. That means the distance from here all the way across here. But I only have like this guy labeled right here. Like that's the only part that's drawn. That is going to be 6 because that's a radius. So just that little bit is going to be 6 units. All right, let's keep reading. Next, circle J, his diameter is 20 units. So that means this guy, circle J, I was going to switch colors. This circle has a diameter of 20 units, which means from here to here is 10, and from here to here is also 10, okay? And they're overlapping this little bit in the middle, which I don't know what that is, but we'll figure that out here in a second, okay? Then they say JD. The distance from J to D is 8. Okay, and they want us to find some stuff. So this isn't a terribly hard problem. It's just like hard looking at it and seeing what all they're like labeling, okay? So from there to there is 8, but I know from here to here is 10. That means this guy must be 2. This little bit that's here in the middle, that means that this guy must be 4, right? In order for them to add up to be 6, okay? So it's not that hard. We just have to like find our labels and stuff. They want us to find EK, which we just did. The distance from E to K is 4. Okay, again, here to here is 10. This bit was 8 that they told us. So that means, let me go again. Here to here is 10. This bit is 8. That means this guy must be 2. But we know this whole bit is 6. So that means this guy has to be 4. So EK is 4 units. Okay, not terribly hard, but just map it out and write on the diagram. Like write out your distances and your lengths on the diagram. Okay. All right, not too terribly hard of a section, I guess, to start chapter 10. I do have quite a bit of a homework assignment for you, but some of these are very, very short, like naming everything. Those are really short. 4 through 8 is this whole chunk right here, 4, 5, 6, 7, 8. Those are naming things. Then 12 through 14 is those 3. 16, 18, 22. I'll go back up to the top so you can see these all together. 25, 26, and then 30, 33, 34, 35, 36, and 38. Okay, I'll go back up to that list up here at the top. So these 3 pieces. Come on. What are you doing? These 3 little chunks are all like ranges. Otherwise, these are just individual questions. So 4 through 8 all, 12 through 14 all, and then 33 through 36 all is those problems. So it looks like a little bit longer than what we're normally used to, but, you know, the problems aren't terribly don't take terribly long. Okay, there you go.